Alrighty, good morning everyone. I put together a couple of lessons for us to focus on some of the computer applications technology theory, especially some of the components that were brought up in the final exam from last year. So these are in addition to all of the standard theory concepts. A lot of these are already in the theory concepts booklet, and at the end of this slideshow we'll also look at some concepts that you might want to look into, the things that might come up in future in CAT. Okay, so let's get into it. These are the ones that we're going to be looking at. We're going to be looking at the first one, virtual reality. We're going to be looking at the Internet of Things, or IoT. We will look at M-learning. We're going to be looking at a VPN, at what big data is, and also what GPS is. These are not all your theory concepts by any means. These are just some of the ones that you need to pay attention to. These were mentioned in the NSC paper last year, in 2019, and it's highly likely that these and others will come into your exam this year. Let's get into it. The first one we're going to get into is VR, virtual reality. Now, most of you have at least heard of this before. Some of you have experienced it. It is when you use some complex hardware, usually a headset and some kind of motion sensing equipment as well, to give yourself a completely immersive experience. So virtual reality is different to augmented reality, because augmented reality is when you add or overlay something to the current reality. But virtual reality is when the entire experience is virtual. Nothing in it is actually real outside of the headset. This can be useful for things like training people on to do tasks or to see environments which they would never be able to safely see, either medical training, military training. Plus they are very helpful for entertainment as well, and they're quite exciting to have a completely virtual experience. The problem with them is usually very expensive, and the software that operates, you need special software that's written for virtual reality applications. You also need very powerful hardware to actually run the virtual reality or the VR application. Let's move on. So the next one is Internet of Things. This is quite important. It's been in the syllabus for a while now, and it's becoming more mainstream. Either IoT or Internet of Things. This refers to the billions of devices and options that we have that can be connected together, and that can share they can share data. They can communicate with each other without a human intervening. And we can actually receive data from these millions of sensors all over the show. An example of IoT, for instance, there is the bottom left is these smart Wi-Fi light bulbs, which have sensors inside them that you can program by app to turn on and off or change the colors. Other examples of IoT devices are things like a thermostat in your geyser, or a geyser timer that you can access or control remotely. Some appliances are IoT compatible, things like home security cameras, some appliances, Bluetooth speakers, things around your house that can have sensors in them or that can be connected. Usually we use the word smart before the item to tell us that it's a bit like your smart TV as well, to tell us that it is part of an Internet of Things device. And usually we don't call our smartphone or our computer an Internet of Things device, because the IoT, our cell phone is for humans to actually use, and uses a lot of intervention, whereas IoT devices are designed that humans do not need to intervene. They can be more autonomous, and the device can do things and communicate things remotely or without any human interruption. And they are nice because, an example of this is also, say, a smartwatch that measures your heart rate, because it gathers data and you can make decisions based on that data. And more and more you're seeing things that have the prefix smart in front of them. Smart light bulbs, smart geysers, smart watches, even some refrigerators are kind of smart. They are connected remotely, and they can notify people if you're running low, running out of milk. Okay, next one we get to M-learning. Now, usually you would have seen the term e-learning or electronic learning before. which is like you're doing right now. You're watching a video using a computer or a laptop, watching it on the internet. Whereas M-learning stands for mobile learning. And mobile learning usually takes place between a learner and an organization or a content creator, and you would use a phone or a tablet to access that M-learning system. So the system could take many forms, but it would usually be a very small, a short time, and it would be a really kind of simple and quick learning opportunity that you would engage in. So whereas e-learning would be more a long-term course where you would get assessed at the end and there'd be many hours involved, whereas M-learning is designed to be quick, almost quick inputs, easy to do on a cell phone, very bite-sized chunks of information that can be assessed quickly, and you can access it on demand. You don't have to be at your computer or your tablet, but you do have to have an internet connection to make use of mobile learning or M-learning. Alright, then we can move on to a VPN or virtual private network. These are covered in some of your notes, but they are becoming more common, and some of you have probably used them before. So VPN gives you a secure kind of end-to-end encrypted connection to the internet. So, for instance, in real life, what people would use, if you wanted to work from home, as many of our parents are doing now, working from home, your documents and your files and your emails would all be sitting on the network at work, the secure network at work. But you are now at home and you want to access those files and that content, send emails and see all your files. So you would have to then create on your computer a virtual private network to virtually connect to the work network, and then once you're signed in, you could see your files and you can communicate with and access all your documents without anyone being able to see the communication in between, so to be encrypted, which is good, because if people are able to what we call snoop your data connection, which often would happen at a public place like a coffee shop or hotel or airport, if you're using their free Wi-Fi, people could be watching what happens and what is transferred between your device and the internet. And if you were sharing information or sending emails or doing banking on those networks, people might be able to see your details. Whereas if you're using a VPN, your data becomes encrypted, your usage is encrypted, and no one can snoop on your data in between your device and the app, the node where your internet connection is made. Let's just go back. Sorry. So this is great because it gives you some level of security. It gives you a level of anonymity as well. There are many free options that you can get online. Some you pay for, some are very expensive, but others are fairly low cost. You can even have a VPN that allows you to connect via your home networks. You can see your home files and your home devices. You can even watch a movie on your home network if you had a VPN that you could access remotely. You could be on holiday and you could use your phone to create a virtual private VPN connection right to your home. No one would be able to see what you were doing. It's encrypted on both sides. Okay, so let's move on from VPNs to big data. Okay, and the concept of big data is having and gathering and processing these massive amounts of data, usually very quickly, and giving you some good insights. And the nice thing about data is that the more data you have, the better decisions you can make. So people use big data, and the internet makes it easy to gather big data, right? Because people often use the big data that is gathered from your Internet of Things devices, like your smart watch that's measuring your heart rate. Now, on some server somewhere, they are gathering all those heart rates from people's watches, and you can now find information about that. You can track what is people's activity like. On the internet, you can track what websites people go to, what they look at on social media, and without knowing who the people are, you can still see what is the general trend that is happening. What are people buying? What are people interested in? How can we target them with advertising? What adverts do people want to see? You might be able to use big data for looking at business trends, like how is the market changing, or how is the stock price changing over time. You could look at things like property rates or or properties up for sale, and see what areas are looking attractive to purchase property in. What we can also use big data for looking at things like disease prevention, or analyzing environmental patterns, or things that happen in the climate or the weather, because you just have all these sensors all over the show. So people do, they have weather stations all over, and you can actually gather that data, like billions and billions of data points of temperatures or pressures. Or with diseases, you could look at millions of cases of diseases, and then you could analyze those and track them and manipulate the data. So that's the concept of big data, is having these massive data sets that you can't really analyze using traditional methods like a spreadsheet program, or not even a normal database. Even normal computing methods you can't analyze. So usually the companies that do big data processing are these big analytical companies with big hardware and software and very complex analytical and statistical skills. Then we move on to GPS. So GPS, often in CAT, we look at how it relates to our cell phones and tracking various devices. So GPS is a global positioning system. And the way it works is that it started off with the American government releasing or launching satellites. They were not satellites with cameras, they were satellites that broadcasted a signal. And we knew exactly where the satellite was in its orbit. So the way it would work is that in your cell phone today, your cell phone has a GPS receiver, and if your phone can pick up the signal of 3 or more of these satellites that are orbiting the Earth, your cell phone knows exactly where it is, can triangulate its position. And the more satellites that it can detect and it receives signals from, the location can get more and more accurate. So there are many GPS satellites today that just transmit a constant signal, and your phone and your car and your device can all communicate and receive those. Your phone's not sending signals up to the satellite, it's just listening for these GPS signals coming down, and your phone can then navigate. You use this for navigation. And the nice thing about GPS systems is that you can use them even when you don't have access to the internet, or when it's cloudy or raining, because the signals can still be detected even through cloud or rain. And yeah, the technology has evolved so much that the GPS receivers are very small, and they can very cheaply be put into cell phones and tablets and computers, and these days even cars are using GPS technology. You can put GPS trackers on things like containers, or parcels, so that you can track where things are all over the place. You can track things that are floating in the ocean, or things that are flying in the sky, planes, things that are moving. So IoT, or Internet of Things devices, would also make use of GPS at the same time to gather information about things. You can even do environmental science by tracking bird migrations, by putting a GPS sensor on a bird, or tracking wolves, or anything that moved around. Sometimes they track whales and sharks and things like that. Okay, so that's the first. I don't want to make it too long, but those are some things to consider. You can also use your Theory Concepts booklet to check it out. But these are some things which we haven't really gone into detail about, but there are things that you can start to read, because I think these will be amongst others, and we'll go through some more. I'm not going to go through them now. But these are things and terms and concepts which you might consider researching a bit on your own. 5G, well, we know about 3G and 4G LTE, so 5G you can go and look into. Encryption, try and understand what it is and why it is helpful to us and where we would make use of it. Machine learning, you can look into that. You can also look into something called edge computing, and I'll give you another few kind of future trends and concepts that you might consider, just to expand your own mind. Alright, until next time, go well.